symbol up here because I'm a bastard. This 71 is the average. That is the Greek letter for M, small m in Greek. Big M in Greek looks like a big M, but small m for some reason looks like that. It's called mu, M-U. Greek letters make their presence known quite a bit around. We've already seen one yesterday, sigma, big sigma over here. So little mu stands for the population average. I'm calling this a population because that was all of my Math 95 students that term. And I wasn't comparing them to anybody else but themselves. So I'm calling that my population. Very rarely do we have a population sitting in front of us. More likely we're drawing a sample and comparing them to within a population or to the rest of a population. So we usually call that X bar for a sample average. Please, Madeline, yes?
Is that the same one that represents prefix micro?
Yes, it's the same one for micro, the Latin prefix for micro. Yeah, it's exactly the same one. It's the same one, coefficient of friction, you physics guys and gals in here. Coefficient of friction, no, that one doesn't make it. What does that mean? So, well, statistically, very interesting. I've been bike commuting for 20 years. February 2nd, 3rd, somewhere early February, I call it Zamboni Tuesday. The day the mist fell right before sunrise and flash froze everything in bed. Do you remember that? It was the most incredible thing I've seen in 20 years of biking. I walked out of my house, took one step on the driveway and slid all the way across. Thank God I have good balance. I slid all the way across my driveway as I was skating. I'm like, what the hell's going on? Went back inside. Now here's where the dumbass kicks in. Went back inside, changed the tires on my bike to studded tires. Decided, I'm gonna ride anyway! I'm gonna go! Went down, had the worst crash I've ever had on a bike. Left the driveway, very careful, very careful, very careful. Turned out of my neighborhood, must have leaned a micrometer over, micrometer. Went straight down. I've never crashed so fast on a bike in my life. Straight down, tilted, bike shot out, landed on my elbow, shock loaded my rotator cuff, still dealing with it. Now 2 weeks, I'm about 2 weeks out, I think, from perfectly being healed, thank God. 2 months later, that injury. I've never seen, the reason I bring this up, the coefficient of friction that day was 0.04. That is about as low as it can get before you can't use things like wheels and feet anymore. The only reason your car goes forward when you step on the gas is because of friction. It's the only reason. If there was no friction, the tires would just spin and not grab the road. Grab is measurement of friction. Mu is how you denote that in physics. 0.04, ask Professor Emerson. He's like, you fell, you hurt? He's like, wow, did you catch the coefficient? I'm like, no, I was hoping you'd tell me. And did, 0.04. 0.04. The reason you walk forward is because your feet are pushing against the ground, propelling you forward. Otherwise, wouldn't go anywhere. No friction. No friction. Amazing. So it stands for a bunch of stuff. Micro, coefficient friction, average population. So, I walked around and saw that your grass looked great. That's what it actually looked like. That's what it actually looked like. Isn't that incredible? Isn't that, exactly. That blew my mind. I grabbed it, I'm like, what the hell just happened? What the hell just happened? So, my question to this is, should we even look at averages and medians when you got data that looks like this? Remember when I asked you questions, I said, what does it mean to be average? What does the number of an average mean? And what were some of the words you used to describe average?
Some people use stereotype.
Stereotype, middle, common, distributing, right. Now the distributing bit is completely correct. I mean, if you take these crappy exam scores and take some of these really good ones and knock them down and give those points to these kids, then essentially these kids are going to rise up and these kids are going to fall down. And if you do that until everybody has the same number of points, well, it's going to be a 71 average, which means it's right there, essentially. Right there, essentially. But should we use that as a description of what's commonly going on with this class? What is commonly going on with this class? A third of the class does not know what's going on. A third of the class has a B. The other third is mixed in somewhere else. Only about a sixth of the class actually performed at average or median. That's when I started thinking to myself, maybe I need to look at other stuff besides just averages and medians. Maybe I should look also at modes. This is bimodal. This is a bimodal distribution. It's perfectly bimodal. Perfectly. We had 20, 50s and 60s and 20, 80 and 90s. When you got bimodal data, I'd say pay attention to it. Pay attention to the modes. What I then have to do is go figure out, okay, what the hell happened here? If I take that away and look at this, I'm okay with this. This is generally what happens in most of my classes anyway, although it's usually more extreme in 243 and 244. I generally get this. I get exponential distributions in here, which should make you guys feel pretty good, because that's generally what happens in my classes on my assessments. But if I can figure out what's going on over here, I don't just stop and not think about them. I think about what's going on, and as I look deeper, I realize some stuff. Some of those kids were misplaced. They tested it at Math 20 and said, I can handle 95. Maybe not. Some of the kids had stopped coming to class and they were zeros in my grade book. Or excuse me, not zeros in my grade book. They had stopped coming to class and then showed up for the exam and tried to do something basically cold. Well, they got about halfway done. Not passing though. So in other words, there were actually two groups of students. The ones that shouldn't have been there and the ones that should have been there. When you view it like that, you shouldn't group them into one graph. There should be two different graphs. Does that make sense? Again, statistics showing us something instead of just proving something, asking us, okay, why? Why? I think that's the most important thing, asking why, or how, or when, or the other three words I can't remember right now. So when you have multimodal data, I'd really stay away from the averages and the medians, because they tend, you can get a number for them, but the problem is they might not mean anything in context. The one thing I want to talk about last conversationally is, what if you have qualitative data? I put up like hair color, but what if you're talking about like credit card? Like, how are you going to pay for this? Credit card, debit card, cash, IOU, check, COD. Steel? Steel? Yes! I'll pay you in steel. Barter! There we go, barter with steel. I like that. Steel. I love that. Good. So you got all these qualitative. If you had to give the typical or the stereotypical or the common method of payment, would you use the average? Would you use the median? Would you use the mode? You'd have to. You can't use an average because you can't average words. And you can't use the median because you can't put words in order numerically. You can make the alphabetical order, but that doesn't make any sense, does it? So really, mode is your only choice for that, right? You can only use qualitative data with the modes, or you only use modes with qualitative data, because it's the only one that just looks, remember what we said, mode looks at this, then goes down and only references this. Well, for qualitative data, these references are words, and that's okay. You don't need to actually do any math at all. Even the median has a tiny bit of math involved, because you have to put stuff in order first. The mode is the only one that has no mathematical calculation at all involved. So if you have qualitative data, what's typical fish caught out of the Deschutes? Typical fish caught out of the Deschutes River. Rainbow trout, that would be my vote too, is that correct? I'm guessing, as a one-year veteran fly fisherman who sucks. I catch all the ones that are 5 inches. I'm pro at catching little guys out of there. Let them go grow bigger. Let me catch you again. Rainbow trout, because that's what I usually see too. I see rainbows come out of the Deschutes most often. Yeah? Crooked River? I caught a whitefish, I think. Big scaly thing. Terrifying. Actually, I shouldn't say I caught it. I got it 3 inches from me and it popped off. Damn thing in the net. I'm like, I got it! Bastard. Whitefish, yes. So I've heard very common. Very common. Reynolds Pond, channel cats, I don't know, largemouth. So you have to go to the mode then, the most fish that come out. So qualitative data, I think you pretty much are stuck with the mode in that case. Good! You guys got a good handle on that. Let me check one thing real quick. I think I had something I stuck in here. Let me pause that too, because this is a good place to break videos.